Now the second Newtonian laws of motion, also called the law of unbalanced force, says that the rate of change of momentum of a body is directly proportional to the unbalanced force applied and changes in the direction of the force applied. Now the definition of the second law introduces us to a new concept called momentum, which is nothing but the product of mass and velocity of the body. Velocity arises, as I have already told you, there is a change in velocity only due to the application of force, and velocity being a vector, momentum is represented by p, which is also a vector quantity. And we know that unit of mass is kg and unit of velocity is meters per second, and this happens to be the SI unit of momentum. Now by the definition of the Newton's second law, the rate of change of momentum, if there is an initial momentum say p1 and final momentum say p2, then p2 minus p1 is nothing but final minus initial, and it is nothing but the product of mass and velocity, this being final and this being initial velocity and final velocity. And this is the rate of change of momentum. By definition, we are here saying that when we take mass common, this becomes, and the rate of change is, we have to involve the time also, this is rate and this is change in momentum. This is change in momentum and this is rate in change in momentum is directly proportional to the force, says the second law. Here we can explain that a body of mass m moving with a velocity, initial velocity u, due to the application of the external force increases its velocity, its mass will remain the same, will increase its velocity to v in a given time t. This is nothing but rate of change of momentum. If I choose to remove the proportionality, I have to place a constant here, and this is called the proportionality constant. The removal of this and replacing it with equals to, I will have to place a constant, and this will give v minus u by t is nothing but acceleration, which we have already learned in the previous chapter. Therefore this becomes the new formula, and thus we have attained the formula for force from Newton's second law by definition from the momentum and replacing it with acceleration. This is nothing but rate of change of velocity, which comes about the acceleration. And now if there is a mass of 1 kg and due to application of force, if an acceleration of 1 meters per second square has been caused in this, then the value of k will become 1 unit, because as you can see 1 unit force is equal to 1 kg into 1 meters per second square. This is the unit of acceleration, this is the unit of mass. If I want k, then 1 unit force by 1 kg 1 meter second, the value of k will be 1, because the unit of force is again same, so units cancel, the 1 cancel, and the value of k will become 1. And when k is 1, we can say that F equals to ma, and unit of force, SI unit of force is Newton, and Newton is defined as the force. So finally, force 1 Newton is the force causing the acceleration of 1 meter per second square in a body of 1 kg mass is defined as Newton, and CGS unit of Newton is dyne, force is dyne, and 10 power